2.2.4 Agile Manufacturing in Fashion and Textile Industry. The fashion and textile industry conducts business in a highly competitive environment due to intensive globalization, customer demanding expectations, shortened product life cycles, and high volatile
ماركت تشين et al.
2013 نايات 2020 AB.
Several studies explained different characteristics of the fashion industry, including market volatility, short product life cycle, large product variety, low demand predictability, trendy and disposable products, and complex supply chain network. Katchen and Swinney 2011, Lee and Ree 2008, Moon et al.
2017
Fashion customers continuously demand more variety of trendy and seasonal styles, colors, sizes, quality fabrics, and fast delivery. However, their purchase behaviors are highly impulsive. Lemieux et
al. 2012 Nietzsche Faisal et al. 2006
To meet the aforementioned customer demands and expectations, fashion companies have to constantly introduce new trendy styles, clothing materials, and colors by seasons. To attract more customers and satisfy their desire for new apparel, fashion companies are proactively creating fashion trends, increasing the number of seasons, offering a large number of collections.
Various Product Range and Style Lemieux et al. 2012 According to Karugeti et al.
2008 Fashion manufacturers often introduce 4 to 6 collections per year. Several major fashion companies such as Zara, Uniqlo and H&M even present new collection in a weekly basis. In order to offer that constant new fashion, at affordable prices, and fit the trends, fashion companies need to develop agile manufacturing capability to respond quickly to market changes and customer shifting requirements and preference. Moon et al.
2017
Agile manufacturing enables fashion companies to satisfy rising customer demand and stay competitive by building flexibility and responsiveness capabilities, optimized operation processes,
Low Cost and
highly customized products, continuous addition of new customer desired product features, and strong supply chain network. Hassani et al.
2012
Three differences between lean and agile manufacturing. While lean is seen the application of approaches and practices that is focused upon the reduction of waste, Gobeklu and Tang 2014, and enhancement of efficiency. Agile manufacturing remit is to ensure appropriate responses and adaptability in an ever-changing environment. Lean processes are focused upon streamlining activities and operations towards optimization with reduction or removal of non-value-added elements. Campbell et al.
2019
This keen focus is on ensuring the firm maximizes its operational capacities and with it, reduces the costs associated with inefficiency. In contrast, agile manufacturing applies an ideology that focuses upon flexibility, adaptability and the capability to change to uncertainty. Vasquez Bustelo et al.
2007 B. Holgren and Olager 2009
Indeed, in some circles, agile manufacturing has been defined as programs to enhance performance in areas such as responsiveness, shortened lag times towards change and even efficiency in knowledge man.
Edmund Narasimhan et al. 2006 Iqbal et al. 2020 Iqbal et al.
2020 go as far as viewing agile manufacturing as firms, flexing muscles, which are highly adept and can change to altering demands. It is important to note that there are some complementary aspects and philosophies between lean and agile manufacturing, namely in the drive towards efficiency via quality and responsiveness.
Where cost
Waste is the dominant focus in the former, with flexibility a major tenet in the latter. Iqbal et al.
2020
Often the complementary aspects of lean and agile ideologies are both applied simultaneously for the benefit of the organization and the business it is undertaking. Their focus on enhancing effectiveness, efficiency and economy are all vital aspects of business strategy and ideology. Kumar et al.
2018
Nonetheless, while the approaches are often applied in tandem in business operations and considerations, they are known as competing. Holgren and Olhager 2009, and mutually exclusive paradigms. Iqbal
et al. 2020
Several previous research has discussed numerous dimensions where lean and agile differ not only in their principles, but also in the core operational focus between the concepts and in how each develops a competitive advantage for the business. For instance, where lean is focused on continuous improvement in resource and process usage, Agile is focused upon the manipulation of activities to quickly meet ever-changing customer demands. Yusuf.
and Adelaide 2002
Similarly, the focus, objectives and the strategic direction and decisions of the firm often drives the application of either methods. These decisions, survival of the firm, profitability, market share or market entry, can be at considerable contrasts and as a product of this may equate to usage or non-usage of lean or agile manufacturing.
During ideology
Hulgren and Olhager, 2009, argue that a cost leadership approach is more closely aligned to lean management, focusing on cost effectiveness, where flexibility and a strategy of differentiation reflects the ideologies of agile.
Narasimhan et al. 2006 and Vasquez Bastelo et al.
2007a, B contend that the state of the external environment can provide similar contrasting use of either ideology, with lean being the dominant focus in times of economic stability and agile.
In time of uncertainty
Booth and Hammer's 1995 earlier work suggests a similar line of argument, where lean ideologies improve effectiveness and efficiency while reducing waste. It lacks the ability to absorb shocks in turbulent and ever-changing environments.
Harrison 1997 and Inman et al.
2011 suggests that usage of one approach requires trade-offs to be made in the other, with this notion indicating the mutual exclusivity of both approaches, rather than its complementary coexistence. Booth and Hammer's 1995 view contends that lean advances all aspects of the mass production process, where agile manufacturing is more focused on leaving this behind and managing continuous change in requirements as a routine function. This view is shared by Hofer et al. 2012, where agile systems are able to manage variances and derive advantages through flexibility, whereas lean's advantage is to maximize efficiency and with it reduce such variability. Table 1. Table 1 differences between lean and agile.
Dimension Lean Agile Principle
Elimination of waste, customer enrichment through flexibility, perfect first-time quality, change to enhance competitiveness.
Kaizen
Leverage the impact of turbulence and uncertainty.
Production Quantity Enhancement of Mass Production
Break with mass production, emphasis on mass customization.
Market Condition
Fairly stable market, suitable for sequential customization of product families.
Turbulent Market Most suitable for parallel customization as market demand vary randomly Competitive Advantage
Productive efficiency through continuous improvement in resource and process usage. Customer enrichment through timely mobilization of enterprise-wide competencies.
Cooperational Focus
Constant systems check and updates towards flexible machines for JIT deliveries. Manipulate intelligent machines to quickly replicate custom solutions.
Source adapted from Yusuf and Adelaide 2002 and Al-Tahat and Batene 2012. See Conclusion.
The chapter has provided both an overview and deeper insights into the notions of lean and agile manufacturing, its inherent approaches, benefits and the rationale for its use in the fashion industry. Through understanding its emergence and the etymology of both, it provides readers with clearer knowledge of the origins of lean and agile manufacturing and the various dimensions for their successful application with its humble beginnings dating back to pre-World War II. Lean manufacturing fully gained prominence in Japan as part of the Toyota Company's approach to manufacturing. Mirrored in the US by IBM, lean manufacturing ideologies was further enhanced through greater controls via Lean Six Sigma. Indeed, the approaches espoused by lean have gained more widespread usage within industry as a product of its dominant focus on reducing waste and developing efficiencies. Processes that all add value.
To businesses
Agile manufacturing's dominant focus is on ensuring flexibility and with it adaptability to not only customer desires but also to the external environment. Instead of focusing on enhancing efficiencies in standardization, agile manufacturing prioritizes innovation, creativity and systems that can deal with constant flux, allowing quick pivoting to be both proactive and reactive to change. Indeed, adaptive capabilities support the ability to weather uncertain environmental events and provide businesses with the opportunity to survive and at times thrive. Alonso et al.
2020
Born out of a need to be constantly competitive in an ever-changing environment, agile manufacturing promotes an ideology that relishes change and is readily prepared for it. The chapter has also identified that both approaches have a vital role in supporting the fashion and textile industry. In ensuring appropriate quality thresholds without wastage and also developing capacities to innovate as well as weather uncertainty. In essence, while both frameworks differ in their approaches and in a number of dimensions of focus, their complementary use also affords considerable potential for success. Given the nature of FMCG and the seasonality of fashion, agile manufacturing provides a means to build a competitive advantage for the future. Likewise, careful waste management and efficient use of resources through being lean would ensure stability in the business enterprise. As such, while there are differing reasons for either the use of lean or agile manufacturing, appropriate application of both can be highly beneficial in not only ensuring cost-effective solutions but manufacturing that befits the turbulent demands of customers. These notions are fundamental concepts of lean and agile manufacturing and if applied appropriately afford multiple benefits to not only the fashion industry, but to other domains as well.
Reference
Achanga P. 2006 Critical
เครื่องหมายสงวนลิขสิทธิ์ The Author S Under Exclusive License to Springer Nature Singapore Ltd 2022 R และยักษ์ S
Lean Supply Chain Management in Fashion and Textile Industry Textile Science and Clothing Technology
https://doi
Org 10 1007 978 981 192108 7_4 Lean Concept in Fashion and Textile Manufacturing
มาโจจอร์ด1แลมแอนอึนไกเยอร์1ฮังมานอึนไกเยอร์1แอนโมฮัมมัดเรซาแอกบารี2RMIT University เวียดนามโฮชิมินห์ซิตี้เวียดนาม2เจมส์คุก University ทาวิลออสเตรเลียเครื่องหมายสงวนลิขสิทธิ์ The Author
The concept of lean manufacturing refers to a process of manufacturing, starting from raw materials until the delivery of the finished goods to the end users. With prudent management of resources resulting in monetary and time savings, lean principles have helped fashion and textile firms become more competitive and sustainable. Lean manufacturing has minimized waste and in turn reduced costs by applying reforms introduced by Toyota in the 1990s, and from which the technical term, lean, was derived and became popular. This chapter discusses the benefits and challenges of key lean principles in the fashion and textile industry from product, process design and supply chain perspectives using lean operations. Modular design and postponement are two major lean operations that have had a significant impact on the fashion and textile industry. The literature and real case information from the most prominent fashion retailers, Zara, Benetton and H&M, have been used to illustrate lean applications and their implications for fashion and textiles.
Thai Industry
Keywords: lean manufacturing, Toyota production system, lean supply chain, sustainability, fashion and textile.
1. Introduction
Fashion and textile manufacturing has shifted from developed countries to developing countries, NIAC 2015a, b. This can be attributed to the increased labor charges and utility costs that lead to higher cost of manufacturing in developed countries. For example, Australia, once famous for best quality woolen garment manufacturing, has no more manufacturing them. The manufacturing has been done in the developing countries such as China, Vietnam, India and Bangladesh. The fashion and textile manufacturers in developing countries face very stiff competition due to globalization and cheap buying trend by many global fashion brands. It is very hard for many manufacturers working on the traditional technologies to gain enough profit due to rising costs of labor, material and energy. As the manufacturing of fashion and textiles is labor and energy intensive, the manufacturers should focus on the best utilization of the labor force and reduce the energy wastage. Hence, the concept of lean manufacturing can meet these targets and increase the productivity and profitability recently. There has been dynamic changes in the global fashion marketplace compared to the past. Large volume orders are shrinking. Fashion and textile manufacturers are facing volatile and diverse demands in their supply chain, NIAC 2020. Fashion retailers like Zara and H&M have increasingly improved supply chain integration to enhance responsiveness to the markets and at the same time maintaining requirements of cost,
Quality and Speed of Delivery.
A number of contextual factors such as growth of a middle-income population and dominance of e-commerce service providers have meant that fashion and textile manufacturers need to respond quickly to market changes and to produce high-quality but price-competitive fashion items. Lean operations such as module development and standardization processes have been developed to handle flexible and disruptive demands of changing fast fashion trends. This chapter aims to review the development of lean principles and to discuss major techniques that can promote the fashion and textile industries. Section 1 provides an overview of lean operations and lean supply chains in fashion and textile industry. Section 2 describes a framework for analysis of several lean techniques, benefits and challenges in the fashion and textile industry. This section discusses the brief of manufacturing processes in the fashion and textile industries. How the lean concepts can be implemented in the fashion and textile supply chain has also been discussed. The case information from the most dominant fashion retailers including Benetton, Zara and H&M provide enhancement of the lean models. The final section offers conclusions and future directions. 1. An overview of lean manufacturing. After the Second World War, Japan, in an effort to reduce the cost and increase the quality and quantity of production, adopted lean manufacturing techniques. Toyota's Taichi Ono and Shigeo Shingo were part of finding a faster and cheaper way of producing automobiles and pioneered the lean approach. This not only enabled industries to maintain their competitiveness and increase innovation by moving from traditional methods to a more flexible system with fewer resources and less wastage, but also increased their profitability. The introduction of lean manufacturing methods by the Japanese car manufacturer Toyota Motors paved the way to a huge Japanese success in the industry and eventually led to change in the whole market. Through the strategy initiated in the car industry by Toyota Production Systems (TPS). Observing the tremendous success of TPS, many other industries then started applying lean manufacturing to wider areas, ranging from electric and electronics, automobiles, machinery, wood,
Netting tool.
construction, ceramics and clothing. Depending on available funds, technology know-how, demography, culture and skills, the adoption of lean manufacturing principles varied from company to company. Various factors have been noted as limiting some companies when introducing and comparing performances by using lean manufacturing across different industries. Business organizations are increasingly looking for new and better ways of operating as they strive to remain competitive in a fast-changing global economy. This has meant that some companies are moving away from a traditional operation to more modern methods which have included lean operations, using fewer resources in a more efficient way to achieve elimination of waste. This innovative approach to reduce wastes has helped organizations to increase productivity using shorter cycle times, producing higher quality for lower cost than non-lean systems. The implementation of lean production has been achieved by professionally managing resources in such a way as to enhance quality, reduce lead times, reduce costs, and minimize waste while increasing
productivity.
In lean manufacturing, the word input is used to mean the physical quantity of resources used and their cost, while the word output means the quality and quantity of the product sold along with corresponding customer services. From the main goal of minimizing waste, lean manufacturing helps a businesses maximize customer value, achieve the organization's goals through producing outstanding output while using less input. It is to be remembered that effective and efficient use of resources with a minimum of zero waste is one of the main pillars of lean manufacturing. To the development of lean manufacturing production, ongoing efforts to maximize productivity within the manufacturing system have been continuously advancing towards lean manufacturing. This has involved tremendous contributions by human personnel at different milestones in the development of the Productivity Efficiency Initiative. Therefore, the following chapter concentrates on highlighting significant cultural periods in lean manufacturing. Table 1 discusses the chronological developments of lean manufacturing starting from the 18th century. Table 1 Chronological developments of lean manufacturing.
Year, Invention, Inventor, S. 1799
Interchangeable parts.
Eli Whitney, 1850
The method was spread all over the industrialized world, American system of manufacturing.
Eli Whitney, 1881
Time study and standardized work.
Frederick Winslow Taylor, 1911 Scientific Management, Frederick Winslow Taylor, 1913
The assembly line technique of mass production.
Henry Ford, 1919 Motion Time Study, Process Charting, Frank and Lillian Gilbert, 1920 Statistical Process Control, SPC, Walter Sheward.
The concept of implementing total quality management, TQM.
Edward Deming, Joseph Juran, and Philip Crosby, 1950 S. Toyota Production System, TPS, Taiji Ono and Chichio Shinko, 1990
The popularization of the lean manufacturing concept.
James T. V. Mack, Daniel T. Jones, and Daniel Rose 2, 1A Conceptual Framework.
One of the first attempts to establish a waste reduction principle in lean manufacturing involved interchangeable parts, Charnin and Vienazinding 2012. An interchangeable part is a concept of producing identical or nearly identical parts that can be inserted into an assembly without the extra effort of customization or craftwork. The concept was first raised by Honoré Leblanc in France in the mid-18th century, Alder 1997. Notwithstanding, it was Eli Whitney in 1799 who popularized the concept and formed the first stage in lean production and just-in-time, JIT, Colson 1944. This was the remarkable outcome originating from a musket manufacturing contract that Whitney negotiated with the U.S.
Army in 1798, Woodbury 1960.
Despite an unachievable goal required under the contract, the effort enabled compatible parts of muskets to be easily mass-produced and replaced, which reinforced a strategy involving a combination of interchangeable parts and mass production. Simultaneously, the strategy involving interchangeable parts standardized the manufacturing process and eliminated extraneous steps, allowing unskilled workers to create and repair weapons rapidly at a fraction of the usual cost. Eventually, the concept of interchangeable parts spread to all areas of manufacturing and became well known as the American System of Manufacturing, Sawyer 1954. This soon conceptualized the waste elimination principle, since, before interchangeable parts, incompatibility of products had led to difficulties in assembly, causing expensive and unrecoverable costs for material and labor. Despite the evolution and popularization of the interchangeable parts concept in America, the labor-intensive approach had prevented this initiative from performing to its optimal potential. Due to this limitation, Frederick Winslow Taylor had attempted to advance worker efficiency. His analyses were based on observing individual workers and their working methods and later published as Time Study and Standardized Work, Drucker 1999. All of the publications were produced as part of a new management class known as scientific management, or Taylorism. Created to guide contemporary management boards with economic efficiency improvement, especially time reduction, in the area of productivity, Taylor 2004. The time study was further developed by Gilbreths, Frank and Lillian, who monitored the behavioral and psychological aspects of workers when performing assigned tasks. While Frank Gilbreth aimed to minimize the workers' movements in production ergonomy through motion study, Lillian Gilbreth added the psychological perspective to the research from the study of work. Motivation and its impacts on worker attitudes and overall working results, Gilbreth and Gilbreth 1916. These findings complemented Taylor's previous work and become known as the motion time study. Another contribution to Taylor's time study became known as the process mapping of Frank Gilbreth. This methodology concentrated on identifying and eliminating any non-value-added work throughout the work process, hence delivering benefits such as waste detection, depicting a process flow,
defining,
and standardization, and so on. Lee and Snyder 2007.
2.2 Henry Ford Production System.
Yet it was not until the time when Henry Ford integrated an entire production process, known as mass production or flow production, that he was able to create a foundation for the concept of lean manufacturing. This was in 1913, when Ford created his revolutionary technique of production with consistently interchangeable parts with standard work and moving conveyances, Womack et al.
1990.
In fact, from the view of both the public and the engineers, it was truly a breakthrough in the production industry with the advent of the moving assembly line, Mullen 2007. Particularly, the fabrication process was sequenced with mechanization being used to generate a high quantity and detailed construction of the material stream, labor division, and careful quality control. The lined-up fabrication steps allowed the use of specialized machines and gauges to assemble the vehicle's components all within a few minutes, extracting perfectly fitting end products thereupon. This was truly a revolution in the practice of the American manufacturing style that consisted of a finished product grouped through processes of the sophisticated subassembly and final assembly. Mike
Helsen 2020.
As a result, mass production proved to create many advantages, namely, accuracy, lower costs, fewer workers needed, faster producing and distributing processes, able to deliver higher levels of efficiency.
C. Aristova and Chadeyev 2018, Nayak and Pahai 2018.
Despite those benefits, the flow production had still not reached the optimal point of maximizing the productivity in manufacturing.
Wimack et al.
1990 stated that the weakness of the system derived from an inability to be flexible and restraints on the capability to produce variable and customized products. This prompted other automakers to update Henry Ford's methods in response to minimize those shortcomings. Therefore, the manufacturing techniques of Henry Ford, along with the advent of a statistical process control (SPC), the use of statistical techniques to control a process or production method from Wall Ter Shawart, and the progressive methodology on implementing total quality management (TQM) from Edwards Deming, Joseph Juran, and Philip Crosby in the U.S. and Kaoru Ishikawa in Japan from around 1920 onwards, Alghamdi 2016, can be considered as the foundation for further improvements in the manufacturing industry, as claimed by Dave 2020.
2.3 Toyota Production System, TPS.
It has been asserted that the lean manufacturing technique was only highlighted by the success of the Japanese giant, Toyota. Toyota's concept can be referred to as the Toyota Production System, TPS, which was suggested by Taichi Ono and Shigeo Shingo in the 1950s. The goal of TPS was to increase the efficiency of Toyota production to cut costs, Wahab et al.
2013.
The TPS consisted of two main concepts: cost-cutting, thorough removal of waste, and full utilization of workers' capabilities, Sugimori et al.
1997 FIC 1 FIC 1 Toyota Production System, TPS. Two important pillars for the materialization of this system were JIT and Jidoka.
The objective of JIT production was to produce a necessary item in a necessary time and quantity, Mondon 1994. The principle of JIT required the withdrawal by subsequent processes, the one-piece production and conveyance, the leveling of production, and the elimination of waste from overproducing, SUG.
ไอโมริเอตอัล 1997
The second pillar of TPS, Jidoka, explained the situation when any possible unusual phenomenon or defective condition can halt the equipment or entire production line.
The consequences of Jidoka were to refrain from redundant production and manage abnormal circumstances. Sugimori et al. 1997
To achieve full utilization of workers' capabilities, it constructed a respect for human system that focused on the eradication of wasteful movements by workers, consideration of workers' safety, and inducements for workers to maximize their capabilities with
Eminent Responsibility and Authority. Sugimori et al. 1997
The catalyst that encouraged the invention of TPS was the need to reduce costs in the war-ravaged economy following World War II, Wahab et al.
2013
To be more specific, the consciousness and attitude of the Japanese workforce, the narrow domestic market, the pressure from foreign producers, and the lack of resources drove the changes in Toyota's
Traditional Production. Vinet et al. 1990
The TPS is said to be another revolutionary production management system, along with the Taylor system, scientific management, and the Ford system, mass assembly line. Since it could still generate it even during sluggish periods in the economy, Mondin 1994. This concept was introduced to a broader audience after 1983 with the accentuation of mixed model production, preventive maintenance, and multifunction workers. In addition, the TPS has gone through tremendous changes in practices and improvements since the 1970s. Bamu and Sangwon 2014. 3. The development of lean supply chains in fashion and textile. Since 1990, efficient managing of the entire supply chain has become the most important part of organizational success in the world. Agbari 2018, Koenig and Spindler 2016. Supply chain is defined as the planning and control of the end-to-end production and services, from raw materials all the way to the end customer. Akbari et al.
2017 Malekifa et al. 2017
Lean Supply Chain (LSC) is a smart way of linking a set of organizations by managing the up and downstream flows of funds, information, services, and products, satisfying the end user by the reduction
of cost and wastage. Witasek et al. 2005
Lean manufacturing and supply chain management can be classified into upstream activities such as procurement and supply, and downstream activities, particularly distribution, including warehousing, transportation, retailing, etc., and the integration of logistics and supply chain activities. Akbari and Ha 2020. In general, the textile industry comprises fiber manufacturing, spinning, weaving, knitting and finishing, while the fashion sector deals with clothing and accessories production. Maya et al.
2013 Bruce et al.
2004 defined the fashion and textile industry as all activities, from chemical conglomerates producing dyes, detergents and artificial fibers, to healthcare companies producing heart valves,
Prostate, bandages, etc.
to niche design-driven fashion companies. The industries of fashion and textile are characterized by diversity and heterogeneity, with a volatile market and a wide range of products marked by short life cycles. Bruce et al.
2004 Nayak et al. 2020 B.
As the profit margin of fashion and textile is low, companies tend to produce these products quickly to fulfill the customer's orders and reduce the holding stock. Additionally, fashion and textile manufacturing units are among the most labor-intensive industries, which cost more in developed countries and thus are more likely to be moved to developing countries, which can offer cheaper labor costs. 3. 1. Lean and garment manufacturing process. The typical garment manufacturing process is described in detail in Fig. 2. The input raw materials to a garment are fabrics and trims such as buttons, zipper and thread. Firstly, the fabrics is being inspected for quality before going to a cutting section. Different types of fabrics are inspected by skilled people in a lighted board. The accuracy and efficiency of fabric inspection depends on the skill and quality of fabrics. During manual inspection, various fabrics faults, some shown in Fig. 3, are inspected and marked by chalk in the fabrics, which gives indication to the cutting section. Then fabrics are graded based on the points allocated depending on the severity of the fabric faults following various grading systems such as 4-point, 10-point and Dallas system. If the total points exceed the specified value, the fabrics are rejected. Fig.
2. Garment Production Flow Chart Fig.
3. Some fabrics faults found during fabric inspection. Fabric inspection plays an important role as it directly translated to the garment quality. In order to improve the efficiency and reduce the wastage, fabrics should be carefully inspected before garment manufacturing starts. However, some industries neglect the fabric inspection due to shortage of time and lack of facilities. Hence, they encounter a lot of rejections or reworks. For these industries, the implementation lean manufacturing can help to reduce the amount of rejections. Although automatic fabric inspection systems are commercially available, which can provide consistent results at greater accuracy, several industries still rely on the manual inspection due to high cost. Of the automated machines, digital cameras and image analysis software are used for the automatic fabric inspection. Automated fabric inspection systems can be classified as online and offline systems. In the online monitoring systems, the inspection is performed in the weaving machine while it is being produced. In the offline monitoring system, the fabric is inspected after being taken off from the loom by mounting on an inspection frame where the quality of the fabric is analyzed. Automated fabric inspection systems can inspect the fabrics in full width either at the batcher for grayish fabrics or at the exit end of the finishing machine. Automated fabric inspection systems are designed to find and catalog defects in a wide variety of fabrics including grayish, apparel, upholstery, furnishing, dyed, finished.
Denim and Industrial Fabric.
For getting better results in lean manufacturing by reducing waste, it is recommended to have automated fabric inspection systems. Following the quality inspection, the next processes are spreading, cutting, and then bundling, which also influences the quality of garments. Mistakes in cutting or bundling of wrong sizes or different batches can lead to the rejection of garments. The next process is fusing, where some garment components are fused with interlining to provide stiffness or functionality to the fabrics. Then, they are passed to the sewing section where different parts of the garment are being assembled. The sewing section combines various cut components by different sewing machines such as lock stitch and or chain stitch machines or button attachment and buttonholing machines. The last section is finishing, which includes thread cleaning, washing and ironing. Broken needle parts are being checked by metal detection machines to ensure safety of consumers. Finally, the quality of the garments are inspected following various quality standards before they go to the packaging section. Quality inspection plays an essential role in the manufacturing process as it assures the garment quality is being met by the manufacturers. The inspection involves visual checking of the faults present in the garment or inspection of the measurements as per the technical specification. The visual inspection of garment, as shown in Fig. 4, is done to find any stitching or seaming defects, stains, and protruding threads present in the garment. NIAC 2015A, B. The inspection for measurements or different size specifications ensures the right fit of the garments. Experienced quality inspectors perform the garment analysis as agreed by the terms and conditions between the manufacturer and the buyer. Fig. 4. The visual inspection of suits in a garment industry. In traditional manufacturing, the approach is to check the garments for defects once the garment manufacturing process has been completed. Hence, any defects in a process that could have eliminated by intermediate inspection goes to the next process. This increases the percentage defective garments and in many cases the garments are being rejected. Hence as a wastage of materials and labor. Reworking is a common problem in many garment manufacturing industries following the traditional methods, where the garment faults are rectified by opening the sewn components and reworking. On the other hand, when lean manufacturing has been implemented, the approach is to prevent any defective products entering to the next process. This is a preventive approach and confirms that the output from a previous process complies with the quality standards. Hence, the outputs of each process are inspected intermediate inspection to ensure the right quality product enters to the subsequent process. The implementation of lean manufacturing can ensure the production of right product in each step. Painteru 2011. The next step after the quality inspection is the packaging of the garments that pass the quality inspection. During packaging, various tags are attached to the garment and the garments are wrapped in plastics. The garments are either folded, such as shirts, Trousers are kept in hangers such as suits, coats etc. to avoid creases depending on the type of the garment. Once the garments are packaged, they are sent to the warehouse for stock verification and then shipment. 3.2 Lean and Textile Manufacturing Process. A brief discussion of garment manufacturing process and how lean manufacturing can be implemented to reduce the waste have been given in the above section. This section discusses the application of lean manufacturing in the spinning, weaving and textile chemical processes in brief. A brief discussion of the process sequence have been given in Figs. 5, 6 and 7 in the spinning, weaving and textile chemical processes, respectively. The principles of lean manufacturing can be implemented in the 3 different processes to eliminate wastes.
Fig.
5. The process sequence in yarn manufacturing. Fig. 6. The process sequence of the weaving process. Line is optional process and solid lines are mandatory processes. Fig. 7. Process sequence for textile chemical processing. In spinning process, yarn is manufactured from different types of fibers. The spinning process involves steps such as fiber mixing, blowroom, carding, combing for combed yarn, drawing, roving and ring spinning for ring yarns. For rotor and airjet yarns, which gives high productivity directly, the carded or drawn slivers can be used, eliminating other process. However, there are certain limitations of these processes in terms of yarn count, versatility and yarn properties. Various lean tools such as Kaizen 5S, Kanban can be implemented in the spinning processes to improve activities such as quick changeover, to improve cleanliness in the workplace, and promote cooperation among the workers in the workplace. Regular meetings, teamwork, effective communication can assist in implementing lean manufacturing. In weaving process, fabric is manufactured from yarns by using different types of looms. The weaving process involves steps such as winding, warping, sizing, drawing in and then weaving in a loom. An additional step of pern winding is needed for shuttle looms. Various lean tools such as 5S, TPM, Total Productive Maintenance, Kaizen, Kanban, and Six Sigma can be used in weaving to improve the productivity and efficiency. The implementation of lean manufacturing in weaving industries can help to reduce the inventory, changeover time and waste in the loom shed. Skilled top management, team condition and effective communication is essential for successful lean manufacturing. Similarly, the other process, knitting, used for fabric manufacturing can be benefited by the implementation of lean manufacturing to improve productivity, reduce waste and improve fabric quality. Textile chemical processing involves the processes to prepare the greige fabric ready for garment manufacturing. As such, the fabric from loom state is not suitable to be used in garment manufacturing due to shrinkage issues and aesthetics. The chemical processing steps include singeing, desizing, scouring, bleaching, mercerizing, optional for cotton fabrics, dyeing and/or printing and finishing. Lean manufacturing tools such as Six Sigma, 5S, SPC and Kaizen can be implemented to improve the quality of fabrics, reduce the hazards of chemical management, reducing inventory, waste reduction,
and
improve productivity. 3.3 Lean implementation in fashion and textile manufacturing. Researches discussed above. Lean manufacturing refers to the elimination of waste and non-value-added activities within the principle of production while still maintaining an appropriate customer satisfaction.
level.
Such a concept has been applied in the fashion and textile industries to improve manufacturing productivity and efficiency in different contexts all around the world, including both developed countries and developing countries. Examples of lean implementation in developed economies can be found in the US and Europe.
Hodge et al.
2011 found that textile manufacturers benefited from implementing the lean concept by improving their production process and thus enhancing their competitiveness. The study summarized that the most common lean tools used by these manufacturers include 5S, Kaizen, Six Sigma, Quick Changeover, Standardized Work, TPM, Value Stream Mapping, VSM, and Visual Management. Similarly, Manfredson 2016 investigated cost reduction in manufacturing by applying lean thinking to small and medium textile enterprises in Europe. Research has demonstrated 4 main improvements by applying the lean concept in such companies:
E.
Information and communication, team collaboration, changes in stress levels and team performance. The author also suggests that such implementation should include cultural aspects rather than a tool perspective only. In a specific context, The lean concept was implemented in the Ethiopian textile industry by defining and eliminating the main waste sources of resource, production defect, human talent, excessive mo.
Production and Overproduction Mesgep et al. 2013
Additionally, the implementation of lean manufacturing was proven to promote sustainable development in the Portuguese textile and clothing industry.
Maya et al. 2019
In contrast, Com and Mathazel 2005 demonstrated that lean implementation, which is suitable for the capital-intensive textile industry in the US and Europe, is also working well for labor-intensive textile companies in developing countries. The lean concept helped Chinese manufacturers in identifying the need to process bottlenecks and downtime, thus providing opportunities to reduce lead time and increasing productivity and quality.
Control.
In this case, VSM was applied to observe how many touches relate to material handling were made for each product and qualify the added value of these touches. Detected excessive touches were eliminated or combined with others to reduce the total number of touches. As a result, the revised process provided a significant improvement in the manufacturing throughput.
Duran Sotelo et al.
2020 also found that lean management could help Peruvian textile SMEs reduce the order fulfillment times. As a result of lean implementation, such companies experienced a reduction in problems, an increase in productivity and a decrease in manufacturing cycle time. They recommended that frequent training in lean manufacturing for workers was necessary, along with a need for continuous monitoring to create a long-term lean culture.
Salesia et al.
2012 demonstrated the beneficial results of lean implementation in Indian textile manufacturing with the combination of Kanban, 5S, Kaizen, VSM and Poka-yoke. The studies of Shah and Hussain 2016 and Buddha et al. 2013 examined lean practice among Pakistan textile companies and concluded that the most popular lean tools used in the sector included 5S, Kaizen, quality control circles and single minute exchanges of dye SMED.
In the context of Sri Lanka, Kedas et al.
2012 found that lean application in the knitting industry was more challenging than the garment sector because of the long life product cycle time and the mass amount of production. However, success in lean implementation has helped these companies reduce lead time and achieve financial profits. The key factors for implementation in Sri Lanka included the method of introduction and the order of implementation, Silva et al.
2011
Lean implementation in fashion and textile manufacturing follows the main 6 indicators. 1. Elimination of waste. 2. Continuous improvement. 3. Multifunctional teams. 4. Just-in-time production.
N. Delivery 5. Integration of supplier and 6. Flexible Information System Sanchez and Perez 2001 Coulson and Alstrom 1995 Com and Mathazel 2005
These indicators will be discussed as follows. 3.4 Elimination of waste in fashion and textile manufacturing. The core process of lean manufacturing is defining different types of waste and non-value added activities and removing them from the production process. Within the fashion and textile sectors, common wastes and recommendations for eliminating such wastes have been extensively discussed in the studies of Mesgeb et al.
2013 and Tucker and Joseph 2015
Different types of wastes and their elimination has been discussed in the following section. The first type of waste in this industry is utility waste. This type of waste is quite common in all industries and may come from several sources, including negligence by personnel, lack of resource utilization and other inefficiencies in the workplace. Examples of this type of waste included leaving lights on during daytime or after having left a room, PCs left running 24H, machine runoff during jobs, ventilated rooms and running water tap. However, eliminating this type of waste can be achieved easily by posting reminder notices and monitoring the machine downtime when it is out of operation. The second type of fashion and textile manufacturing waste is the overproduction of goods like fabrics and yarns. Such waste implies the fact of producing goods too soon or much more than necessary or that can be consumed. These wastes need storage place and labor, which increase the overall cost.
To avoid this type of waste, Mesgeb et al.
2013 recommended that factories communicate better with their customers and focus more accurately on their dynamic demand. The third type of waste is human waste. which refers to a failure to utilize the company's manpower. As fashion and textile manufacturing companies are labor-intensive, the gap between the number of employees required and the actual labor force has resulted in significant losses during the production.
process
In several instances, the labor force has to wait for a long time due to improper work allocation and lack of synchronization. Another form of human waste is loss of talent, or a waste of creativity when a company fails to recognize the ability of employees, and that leads to a lack of suggestions for improvement generated
in the company.
Therefore, it is necessary to respect employees and better connect with them through use of clear guidelines and compensation packages motivating them to take ownership of their areas and processes, and encourage them to become involved in all improvement processes by offering package rewards. The fourth type of waste is the waste of defective materials, consisting of both input and output defective materials. For example, defects of input materials for garment manufacturing might be caused by the defects present in the input fabrics, which is the major raw material used for garment manufacturing. Many of the garment manufacturers outsource their fabrics from fabric suppliers. Due to busy schedule, the garment manufacturers often skip the fabric inspection process, which leads to several defects in the sewn garment. The garment manufacturers should have the fabric inspection system in-house, as shown in Fig. 8, or they can get it done by the third-party fabric inspecting agencies. Sometimes, the fabric inspection reports received from the fabric supplier can be referred as a guideline on the fabric quality. However, in some instances the fabric report may not be accurate as it is prepared favoring the fabric manufacturer's Fig. 8 fabric inspection system in a garment industry. The fifth type of wastes relates to the defects produced by technical reasons like damages in the loading-unloading process or lack of skilled employees. The output defects happen with the finished products, possibly due to incapable processing, lack of control, incorrect orientation, or incapable suppliers. Defect examples in textile manufacturing may be needle holes, stains, and skeeved stitches. To eliminate these wastes, garment companies must provide on-job training for employees and standardize operation processes. Islam 2021 recommended that Pareto analysis is useful to identify garment defects, as 80% of defects often happen due to 20% of common causes. The last type is a waste of motion and transportation, excessive travel by people and machines, caused by unorganized space and tools, constantly turning and moving products during assembly of heavy objects placed on high or low shelves. Inappropriate workflow management also causes excessive material movement in material warehouses, cutting, sewing, and finished warehouses. This type of waste can be reduced by defining and removing non-value-added steps and standardizing working procedures.
3.5 Continuous Improvement.
The next important indicator of the lean concept in the fashion and textile industry is how companies continuously improve their manufacturing processes. According to Sanchez and Perez, 2001, this cannot be done without the engagement of all employees and support from the management team. Through a case study in China, Shah and Hussain, 2016, concluded that such improvement can be achieved if a company pays attention to training and develops improvement focus groups. This will lead to product quality enhancement and reduce the average processing times. Adopted from Sanchez and Perez, 2001, one could measure this continuous improvement process at fashion and textile manufacturing by recording the number of suggestions per employee each year.
The
portion of suggestions to be implemented, the benefits of such implementation, the percentage of defective parts changed, the percentage of the non-working machine, and the human resources used in quality control. 3.6 Multifunctional teams. Another lean indicator in manufacturing is how employees can perform a variety of tasks when their teams are likely to rotate more than normal. This creates flexibility and adaptability by companies to accommodate changes in manufacturing levels. The implementation of multifunctional teams requires greater effort in training employees to accept more tasks. This implementation will also possibly reduce indirect costs as workers also take over the tasks of maintenance and handling materials. Carlson and Ahlstrom, 1995. 3.7 Just-in-time production. The JIT concept refers to the delivery of the right products with the necessary quantity only when they are needed to minimize the buffering level. JIT helps the factory to reduce inventory level, thus reducing the carrying cost and inventory management tasks. It increases product flexibility and reduces the working space and overheads. The implementation of JIT also reduces the setup time and the lead time within the manufacturing. Gilmore and Smith 1996. The JIT concept has a long history in the fashion and textile industry. Hokoma 2010 studied the awareness and implementation of the JIT concept in the Libyan textile industry. A survey was conducted and obtained 136 responses from 60 targeted companies in Libya. The result found that half of those companies did not implement JIT at all. 41.7% were not very sure about their JIT implementation and only 8.3% successfully applied JIT within their organizations. The main reasons for JIT absence was concluded to be that these companies were not familiar with JIT. Other significant reasons included a shortage of top management support and a fear of high expense for such implementation. Therefore, the study recommended the management body in the textile industry pay more attention to JIT, enhance the education and training programs and provide more support to achieve high manufacturing outcomes in textile
Factoring.
In another research, Yam 1994 discussed the JIT implementation at small Hong Kong garment factories in the 1990s as a solution to counter high land expenses, increasing labor costs and growing competition from Central America, Indonesia and Eastern Europe. As explained in the study, the garment industry in Hong Kong at that time comprised 7,737 factories, in which more than 80% were small with less than 50 employees. For these small companies, the demands were volatile in both quantity and style as they were more likely to manufacture products which were less economical than for large companies. Implementing JIT in Hong Kong was also challenging as the textile suppliers and their customers were located overseas. Yam 1994 concluded 5 main suggestions for successfully introducing JIT in the garment industry were as follows. First, the JIT transition requires commitment and active involvement from senior management. Second, the company needs to strengthen the coordination with the supplier to achieve JIT delivery of raw material. The shipment of such raw material should be standardized for smooth handling with high-quality products for fewer inspection activities. The next key point for JIT is educating and training the employees, i.e., managers, technicians and operators to improve their flexibility with changes in non-productive skills like preventive maintenance. The case study demonstrated that education and training could help these small garment factories in Hong Kong overcome the issue of work culture from the majority of Chinese workers that was hindering
Teamwork.
2 other suggestions included using group incentive plans to encourage teamwork in manufacturing and facilitate identifying the issues via teamwork. 3.8 Integration of suppliers. Textile factories could also integrate with suppliers to achieve lean thinking in many disciplines, i.e., co-designing. Integration of the information system for better sharing. Exchanging technicians are developing long-term contracts with suppliers. This implementation supports JIT practice, enhances productivity and contributes to the resilience of the fashion and textile supply chain. Nayak et al.
2019 4 Flexible Information System.
Last but not least, lean manufacturing requires a reduction of the hierarchy level within a company to facilitate the diffusion of information at all levels. A flexible information system should allow the timely delivery of information between top management and the production line, and between different company departments and groups of employees. Such flexibility of the information system could be measured by the frequency of the employees receiving information, the number of meetings between managers and employees,
How many procedures are
standardized and recorded, and how many decisions workers could make without asking management. Excessive paperwork is a type of waste in manufacturing, and developing a flexible information system could reduce the amount of time and efforts in processing documents by decentralizing responsibility.
IES to Field Worker, Com and Matisel 2005.
4.1 Lean implementation to achieve sustainability in fashion and textile industries. Implementing the lean concept in manufacturing not only has an economic impact on the fashion and textile industries but also contributes to sustainable practices by companies. Fashion and textile industries are known to consume a large number of natural or man-made resources, i.e., water, energy, natural fibers and dyes, and release chemical waste which highly contaminates the environment. Akbari et al.
2020 Maya et al. 2019 Nayak et al. 2020 A. B. According to Morera et al.
2010, appropriately implementing the lean concept would lead to eco-efficiency practices in this sector. Their study synthesized the literature and concluded that there existed a causal relationship between lean implementation and environmental performance enhancement. This shares similarity with the study of Maya et al. 2013, which demonstrated that by applying the lean concept, textile SME, small and medium-sized enterprise companies could reduce the energy and water consumption, the use of raw material, and thus reduce the environmental waste. They recommended the application of the toolkit by the US EPA, US Environmental Protection Agency, 2018 in implementing lean strategies,
E.
waste elimination culture, Kaizen events and just do it, standard work, visual control, 5S and total productive maintenance.
Situlo et al.
2018 also confirmed that the lean practices supported a sustainable paradigm in the garment sector. An example could be shortening the supply lead time would lead to the reduction in carbon dioxide emission and the creation of new jobs in the region.
In another research, Maya et al.
2019 suggested such implementation should base on a holistic approach, which considers the 4 dimensions of people, ergonomics, sustainability and operation. Sustainable business practice requires the following 4 enablers from the lean concept as listed by Caldera et al.
2019
First, green strategies in a lean concept should be integrated to achieve business sustainability.
These share similarity with Ra et al.
2017, who also provided guidance that lean production and environmental sustainability should be implemented hand in hand, given the case study of Indian apparel manufacturers. The second enabler is the continuous improvement in the manufacturing process by leveraging a lean concept and green practices. The approaches of 5S and VSM are recommended in this enabler. Next, the successful achievement of business sustainability requires stakeholder involvement, both internal and external. The former are the company's employees, managers, and owners, while the latter consist of suppliers, customers, society, central and local government. The last enabler requires the company to have streamlined processes in place, which help a company increase transparency and traceability. The lean concept supports streamlining by standardizing their processes and thus adhering to international methods. The study also synthesized 6 barriers to sustainable business practice,
E.
Lack of education and awareness, lack of financial resources for implementing lean and sustainability strategies, high risk in the implementation. Eco-economic decoupling in a weak regulatory environment. 5 lean operations, benefits and challenges in fashion and textile industry. A lean operation is a flexible system that uses considerably fewer resources,
E.
activities, human resources, materials, energy, and floor space than a traditional system. Lean principles help fashion and textile firms become more competitive and sustainable. The apparel industry is characterized by a short product life cycle, relatively high variety, uncertain demand forecast, which often contributes to inefficiency in the supply chain. Taplin 2014.
Literature indicate that
The value added of garment in supply chain pipeline represented a small part of the total lead time, only 11 weeks out of the 66 weeks that was required on the actual garment. Value-adding processes. The remaining idle times represent waste activities such as work in process and finished inventories at various stages in the system. Oftab et al.
2018
This inefficiency could lead to overstocking or backlog and stock out for the fast-moving high-demand items. Literature has estimated losses of $25 billion relating to the idle times. Oftab et al.
2017-2018
5.1 Lean Goals and Supporting Techniques, Benefits and Challenges. The goals for lean operations are to eliminate disruptions and to create flexible systems to meet diverse customer requirements. Due to rapid changes in customer requirements such as fast fashion, the aim of the lean systems is not only cost reduction but also to create a balanced, continuous and flexible flow of fabrics,
trim,
garment accessories and finished products. The key foundations of a lean system include Stevenson 2005. Product design and process design, organizational and network. Manufacturing control and planning. Manufacturing control and planning consists of several toolsets as level planning, resources allocation and push and pull planning. These tools have been well developed for a specific industry. This section discusses some key benefits and challenges of lean principles in the fashion and textile industry from product, process design and supply chain perspectives in lean operations. Fig.
9.
Modular design and postponement are two major lean operations that can significantly impact on fashion and textile industry. The literature and real case information from the most prominent fashion retailers, Zara and H&M, will be used to distinguish the lean applications and their implications for the fashion and textile.
Industry. Fig.
9. Lean production. Key foundation source adapted from Stevenson.
2005.
Due to rapidly changing fashion trends, garment manufacturers have faced volatile demands and diversity in customer requirements. Fashion retailers have increasingly pushed supply chain rationalization and improved channel integration to force garment and textile manufacturers to be more responsive to cost, quality and speed of delivery requirements. Besides, the growth of e-commerce platforms, fashion and garment manufacturers need to respond as fast as possible to models and quantity changes and to produce high quality but at the same time cost competitive fashion items. Manufacturers need to consider a new production system that can handle flexible and relatively simple modular designs and use standardization concepts to enhance the efficiency of the production system.
EMS 5.2 Lean Technique Standard Part and Processes.
The use of standard parts and processes means that workers have fewer parts to deal with, lower training times and costs are reduced. These concepts of lean principle can be applied to purchasing, material handling, and checking quality, which are more routine and can be improved on an ongoing basis. The basis for this standardization allows garment manufacturers to follow the same protocol and the ability to use standard processing that will lead to cost reduction. The economy of scale and learning curve theories justify the efficiency gain in these processes. Fast fashion companies like H&M and Zara all deploy to a different extent the standardization concepts in their design and manufacturing. Sweden's H&M and its business concept dominates the more affordable mass markets. Since its mission is to offer fashion and quality at the best price, it relies upon large production volume and an efficient logistical system to keep costs low. When designing a product, firms tend to use a common standard such as Virtual Human Body (VHB) standard from the International Organization for Standardization (ISO), specifically used in virtual garment systems in the apparel field, as suggested in ISO TC 133, WG2, Kim et al.
2019.
By using the same standard, the design process can produce a large amount of styles, demonstrating that production volume and an efficient logistical system can be competitive when sharing the same fixed costs such as initial investment and prototype development. Encouraging results after implementing these principles will lead the way to reach the critical mass that will allow companies to compete in these markets. Research indicates marvelous benefits of standard operating procedures, including a decrease in sample rejection level by 60%, reduction of work level for repairing works by 70%. Eliminating bottleneck results in a reduction of excess motion and non-value added works by 50%. Sivakumar 2015. Zara, the major fast fashion retailer and brand producer, utilizes process standardization to reduce new product development lead time and enhance the variety of fashion items. The company employs process standardization during fabric manufacturing, which often have a longer lead time than other processes. It happens during several stages including procurement, design and distribution. First, by accumulating undyed fabric procurement, buyer power has increased significantly due to the accumulation of inventory in the warehouse for undyed materials. Secondly, the discount can be applied to major procurement processes and being flexible to meet customer demand. Depending on the final marketing and order details, the company can adapt to different colors by dyeing in own manufacturing facilities. Businesswire 2002. Before the standardization process, there were several issues related to quality assurance on the pattern size, shape, and measurement, which eventually affect the quality of the garment. After standardization, firms minimize the quality assurance on the pattern size, shape, and measurement, which will be altered before mass production. Importantly, this process eliminates the non-value added activities e.g. repeated measurement, duplication in tasks. Since fabric supply is an essential part of any fashion and textile supply chain, Process standardization also helps significantly to reduce lead time in the fabric sourcing cycles, Oftab et al.
2017
Zara represents a successful model for fast fashion that offers a quick response to customers and meet a large variety of products due to its process standardization in the design phase of its product.
TS Through Developing Standardized Design Module AF-Tab et al. 2017 5.3 Lean Technique Modular Design and Postponement.
The American Apparel Manufacturing Association, AAMA, has defined modular manufacturing as a contained manageable work unit of 5 to 17 people performing a measurable task, Wong et al.
1991
Modules are clusters of parts treated as a single unit. This greatly reduces the number of parts to deal with, simplifying assembly, purchasing, handling, and training. Standardization has the added benefit of reducing the number of different parts contained in the bill of materials (BOM) for various products, thereby simplifying the BOM lists. In a modular system, processes are grouped into a module instead of being divided into their smallest components. Modular design differs from the traditional method of production that relies on individual employees to perform tasks repetitively by using teams of workers to sew and assemble parts or all of a garment. As a rule, fewer numbers of multifunctional operators work on the machines which are arranged in AU line, Oftab et al.
2017-2018 Back et al. 1996
This team-based approach brings several benefits such as reducing costs, enhancing workforce productivity, and the reaction to customer requirements, Taplin 2014. In operations management, postponing, delaying final processing or manufacturing can be very effective when there are multiple demands, Stevenson 2018. The lean technique can be used for alignment between operations and business differentiation strategy. When markets require a different variant of the final products, the critical mass of semi-finished inventories guarantees a lower level of production costs. Depending on the details of orders, a differentiated end product in terms of form, labeling, and identity could be finalized to meet each market. The example from famous Italian brand, Benetton, a major apparel manufacturer of sweaters, is given here. Using two separate stages, 1 dyeing, and 2 knitting, Benetton can hold on to raw materials of white yarns original and converted them into yarns of different colors later on. The dyeing operation can be separated into mass production, which has often been outsourced for lower operating costs. Depending on the details of final orders, a smaller amount of the dyed colored yarns were knitted into different finished garment products, different styles.
Color and size.
This is often called make-to-order, which offers alignment to differentiation strategy.
Figure 10 provides a schema of the two-stage postponement lean technique in sweater manufacturing. Fig. 10 Lean postponement in dyeing fabric. Source AF-Tab et al. 2017 CODT Customer Order Decoupling Point.
This concept has been used in Zara and H&M production to enhance some degree of flexibility towards demand. H&M, on one hand, relies upon a similar differentiation of fashion basic garments, but with low costs derived from largely sourcing production via subcontractor networks in Asia, most recently Inbang.
Latte, Taplin 2014.
Zara further advances the postponement into design function where modular concepts associated with a highly integrated, customer insight, intelligent unit.
This unit also called Vanilla Bob Design, Howe et al.
2002 updates on trends and tastes that can trigger design functions to select the appropriate color for final delivery. Vanilla Box can be applied at the beginning of each selling season. The designers create a library of design modules that can be tested in the market. The concept design modules are delayed until confirmation of new trends and are stored only in electronic format, which postpones prototype and holding inventory costs, Venkatesh and Swaminathan 2004. Applying the standardization process in design can also guarantee cost benefits through economy of scale in designing and manufacturing delays.
Conclusion.
This chapter highlighted the literature and case studies focusing on the development of lean operations in the fashion and textile industry. The key focus of the chapter is to examine several approaches to enhance lean benefits such as delivery time, reduce various wastes, increase productivity and improve responsiveness to customer requirements to ensure smooth production and distribution of fashion and textile products. Several techniques have been used to reduce waste, minimize disruption and create a balanced flow of products in garment manufacturing, spinning, weaving and fabric chemical processing. A detailed description of implementation lean manufacturing in garment industries has indicated with illustrations from fashion industries. Similarly, the scope of lean manufacturing in various textile manufacturing operations has been discussed in brief. Modular design and postponement have been at the forefront in supporting lean manufacturing. Information from Zara and H&M confirm the importance of lean thinking in the fashion and textiles industry.
Reference
Oftab M. Yuanjian Qi.
เครื่องหมายสงวนลิขสิทธิ์ The Author S Under Exclusive License to Springer Nature Singapore Ltd 2022 นยักษ์ S
Lean supply chain management in fashion and textile industry, textile science and clothing technology.
https://doi
Org 10. 107978-981-19-2108-7_5. Standardized work in fashion industry.
แอร์ชิชผาดวาด 1Abstract
There are standard operating procedures to perform many jobs in fashion and textile industries. The Industrial Engineering Department is responsible to set the standard methods and standard time for manufacturing garments. Time and motion study are used to establish standard time and standard methods, respectively. The establishment of standard time and standard methods of doing jobs reduces wastage in manufacturing processes. This chapter discusses the details of time and motion study, which are used in garment industries to establish standard time and standard methods. The fundamental principles relating to time and motion study in garment manufacturing has been covered in this chapter. This chapter also discusses about the terminologies such as productivity, efficiency, cycle time, changeover time, work balancing, time measurement, economy of motion and time management. Various causes of idle time and bottlenecking are also covered in this chapter. Keywords: time study, motion study, idle time, productivity and efficiency.
1. Introduction
In apparel manufacturing process, it is essential to have standard methods and standard time for completing any work. Time study and motion study are done by the Industrial Engineering section in a garment industry to establish these standards. Betty 2016, Bhattacharya 2010, Cherry 2019. For meeting the exact delivery date, time and motion study are very essential tool. As the production of specific style is performed by different operators, it is essential to know the operating efficiency of individual workers. Norman 2010, Painterselvam 2012. Hence, it is essential to have standard methods of doing the jobs. Similarly, in order to calculate the productivity
E
number of pieces of garments produces in a unit time, it is essential to know the standard time for each garment.
In order to set standard time, some standard and low minute time and motion study are mandatory. Ban 1980
Time study and motion study can be used to estimate the lead time, which is essential to calculate the exact delivery date of products. Mundell 1978, Niebel 1976. Time study and motion study can be used to reduce the events of idle time and maximize the productivity. Without any standard time and standard method, the manufacturing process will be encountering excessive waste. Hence, time study and motion study can be used to eliminate process wastes, which is the fundamentals of lean manufacturing. This chapter discusses the methods of doing the time and motion study in apparel manufacturing. Similarly, productivity has become a buzzword in recent years. Betty 2016. It is critical for the success of industrial firms as well as the country's economic development. High productivity refers to completing tasks in the quickest time possible with the least number of inputs, without losing quality, and with the least amount of waste. Work study is the foundation for creating a work system, Curie 1977. The goal of work design is to figure out how to get a job done in the most efficient way possible. This work study aims to improve existing and planned work methods as well as develop work performance standards. Method study and work measurement are two methodologies that fall under the umbrella of work study. Method study is the systematic recording and critical assessment of existing and planned work techniques in order to develop and use easier and more effective methods while lowering costs. Work measurement is the application or techniques designed to establish the time for a qualified worker to carry out a specified job at a defined level or performance.
2. Productivity
Productivity is the quantitative relationship between what we produce and the resources we utilize to produce it.
I.e.
The arithmetic ratio of output to resources input. Productivity can be expressed in the following way, Bhattacharya 2010. The efficiency of a manufacturing system is known as productivity. It is the principle that governs the production system's management. It's a measure of how well the production factors land, capital, labor, and energy are used. 2.1 Factors influencing productivity. 2.1.1 Controllable or internal and uncontrollable or external factors influencing productivity, Cherry 2019.
A.
Controllable or internal factors.
1.
Product factor. In terms of productivity, THEB.
Uncontrollable or external factor 1.
Structural adjustments. Economic and social changes are both part of structural adjustments. The following are significant economic changes.
A.
Shift in employment from agriculture to manufacturing industry.
B.
Import of technology, and